you can see my PowerPoint.
Yes, ma'am. Ma'am, can you please start the recording?
Yeah, I started recording, I think. Please check.
Yes, ma'am. Yes.
Yeah, okay. So this particular subject is related to functional programming. Functional programming. So before starting with the functional programming, let us look at what are the different types of programming paradigm available, right? So then only we can understand why functional programming and what it is really. So we can able to appreciate what functional programming is, right? So we know many programming paradigm. We started with a procedural programming language. Procedural programming language, for example, the C language, Pascal, earlier case, Copal, so many Potan and Basic, so many procedural languages are available. And in which, if you look at the procedural language, right, we can deal with. We can see the structure of the program. If you look at, there are provisions for declaring the variables, more than one variable we can have, and the control structures are available. And with the help of your control structures, we can able to manipulate the data, right? So we are well versed with procedural programming language, right? But now there is another language called as a paradigm called as a functional programming language, in which if you look at it, it is dealing with only functions. We don't have any control structures. There is no for loop, while loop, no, nothing, right? So with the help of a functional, that is calling a function, okay, by using the function calls, we can able to implement our logic. Okay, so if you, I think you are a final year students, if you are taking any problem from Geeks for Geeks or something, and what happens is there are two ways of solving the problem. One is by using the iterative version, right? And another one is using the recursive version. All right. So any problem in the world can be solved with the recursive version of the logic. We can apply the recursion for any type of problem. So in many interviews, you can come up with a recursion program which will be solved with a very small code, but internally it will take maybe more memory. But you can give two alternate solutions for the given problem. One is by using a recursion, another one by using the iterative languages, iterative control structures. Okay. So the functional programming is the very earlier program. Like actually, the MIT has developed many functional programming languages, and that is the content of this particular syllabus. Okay, so through the functions, how we are going to solve the problem. So the entire syllabus is with that only. Okay, and another thing we also know object-oriented programming. Object-oriented programming in the sense we are solving the problem by starting with objects and then interaction of the object, and we are manipulating the logic inside the object, and one object can call another method of another object, and the message passing mechanism. So many features we already learned, right? But there are no objects concept in the functional programming language. Okay, and we also know the scripting programming language. Usually the scripting language is like a functional programming language, but a little bit of object-oriented features will be available. I can say it is a subset of languages. You might have learned JavaScript, VB yeah, many scripts are available, right? So the scripting languages are we can also use, but it has a limited purpose. Okay, and then logic programming language. Actually, while writing a program, we will instruct the computer what to do, but we will not say how to do. Okay, we will not say how to do, but you are just commanding to the computer what to do. So the logic you will write. So the logic programming language is also available. So I hope that so far you know procedural oriented languages and object oriented languages, two things you know, and also the scripting languages, of course. Now we know we are adding to your dictionary the functional programming language, very important one. And earlier days, what the people thought is, if you know the functional programming concept, you can very well go for other programming paradigm. Okay, it is a very starting stage for all the computer engineers. They will start the functional programming language. They will teach. Okay, it's a very old thing, but we are continuing. Actually, in practically, we are using this functional programming languages in many applications. Okay, and also you can able to write a effective program sometimes. Okay, so with respect to the functional programming languages, what we are going to teach is a Lisp. Lisp is a language, the Lisp language we are going to teach, and the expansion for the Lisp is nothing but list processing. So what is meant by list? A list is nothing but a set of data, and in many languages we can have this. We can consider the list as a data structure. It is nothing but a set, right? So whether it is a compiler or interpreter, the list is the interpreter. You know what is meant by interpreter, right? So given a command, right? Given a set of commands, it will take the first command and produce output, go to the next command, produce output, and so on. But you can think that because the list is an interpreter, it is a slow. It is slow compared to the compiled languages, right? So Lisp is a programming language we are going to learn or discuss. And in this Lisp, there are n forms of languages, n forms of dialects are available. For example, what is meant by dialect? Dialect, if you look at the meaning of the dialect, what is the meaning? If you Google it, you can see some form of a language. For example, English is a language, okay? So the English, in some area, they will talk in different way. In some other area, they will talk in different way. This is a different form of a language that is called as a dialect. So in the Lisp, Lisp is the common word. Under that, we have many dialects, many form of Lisp are available, and some of the things are scheme, closure, and then common, racket, etc., etc. And what we are going to learn is a scheme. Scheme is a very simple language for teaching, for education purpose. So if you know the other forms of dialects, Lisp dialects are understandable. Okay, that is the concept. So now, if you look at this particular timeline, if you look at 1955, the Lisp started, the version 1 started, 1955. See, you can see this is a very old language, but you can see here, if you look at the timeline, 2019 also, we are using some of the languages, right? So 2020, it's not updated now. If you look at this particular thing, we are starting with a Lisp, okay, and then the another form, Mac Lisp. And if you look at it, is the interlisp. Lisp machine Lisp is another variety. I can say it is a dialect. Scheme is the dialect, okay, and nil is a dialect. Frames Lisp, Common Lisp, Lee Lisp, T, Emacs Lisp, Auto Lisp. Auto Lisp, in my education, during my bachelor's degree, I went for internship, that is for Auto Lisp. Auto, actually, internship at BHL. BHL, we have given a project. The project is nothing but we have to develop a framework for the Auto Lisp language. The language is available, there is no GUI available. We have to build the GUI and the typing. We have to provide an environment in which the people has to type their program and then run the program and see the output and then debugging, help feature. It's a kind of editor we have developed, I can able to remember. So I know this Autolisp. I worked on Autolisp in my years, okay, while I was doing BTech. So you also have a Pico Lisp and so many things. So PLT, GNU, GIL, Visual Lisp. You can see this particular period, then some GUI has been developed for Lisp, Closure, and then Arc, and the LFE, and then High. High is the latest one. Okay, so whenever you are developing, somebody is developing a language, they used to give a logo, right? So we are going to learn about the scheme. This is the logo. Very popular one is this scheme, and then this one PLT scheme. PLT scheme logo. See, just look at it. Is lambda. Lambda, actually, what is the concept of lambda? We will learn later. If you see the logo, there is a lambda symbol is available. The programming language is built on a lambda. So let us see what is that. Okay. So let us make it as a surprise. What will be lambda? How to write a program using a lambda? Okay. If you look at this logo, it is for the HY logo. Okay, fine. So this is about, this is actually I am showing it because you have to know from when it started and what are the varieties available. These are all the different forms, and scheme is nothing but these are all the dialects, I can say. And scheme is the one we are going to learn. Okay. And if you look at this one in this particular diagram, this scheme, if you look at it, is a combination of Algol. Algol is one of the very old language. I can say it is the very first language, first or second language developed. So it has got some flavors of Algol and some flavors of Lisp. Okay, so every time, whenever some language is invented, and what you will do, you will just compare your language with others, and you will incorporate some of the features which is available there. So you will be producing a competitive language, right? So that is the way. And after that, we also have a racket. Racket is another form of a scheme. Okay, so we will be installing the racket and we will be writing a program using the racket, but little differences there. What we are learning in a theory and what we are learning in the practical lab, we will be using the racket environment. So little difference. Okay, I tell you what is the difference between scheme and a racket later. Okay. So this thing is already covered by Ms. Sridhar. So this is about the elements of programming. What is meant by elements of programming? Whenever you want to learn something or somebody is inventing a program, they have to provide something so that we can build on the complex thing. Okay, so the base, the fundamental thing should be provided, right? So the kind of called primitive data type. Okay, primitive procedures which will operate on the primitive data type, right? So by using a primitive expression, here we are calling it as an expression, everything is called as an expression, and we can build a small entity called as a primitive expression by using the procedure and by using the primitive data type. Okay, so you know what is the meaning of expression. Expression in the sense, normally in all languages, what is the meaning of expression? A plus B into C divided by D, something, whatever, right? So we can see the operator and then operands, and if you pass the value to the operands, and operator will take that value and process the expression and then give you the result, right? So this Lisp is going to give you some primitive data and some primitive procedures, okay, by which we are going to have a complex things. Okay, so that is the primitive expression and means of combination. What is meant by combination? Combination is nothing but a compound element which are built from the simpler one. So here the simpler cases are variable and then operators, some procedures. With the help of that primitive element, we can build a combination. Okay, by using a combination, again, we can build a compound. We can build another compound abstraction. That means we can build another complex combinations. I can say it is a complex combination. So the complex combinations are possible with the help of nested combinations, and more than one time we are making a combination in our expressions. Okay, and we can also give a name to the combinations. Okay, so this is a very fundamental thing we have to know when we are programming in Lisp. Okay, so now in the Lisp language, in the scheme, what is the primitive thing available? The data is available and the procedure is available. What data, what procedure? First of all, you have to know what data is available, what procedure is available. So the data, we can have integer data, we can have a character data, we can have a float type. That is called as a data, right? So we can be able to define data of different data types. Okay, that is available. And with the data, what you can do? With the data, what you can do? With the data, we can manipulate the data, and we can apply some logic on the data. Okay, so how to provide a logic and to manipulate the data? That is by using a procedure. Okay, so there are simple procedures available, simple data types are available. Let us look at. Okay, so now the step while writing a program, you have to understand the keyword expression. Expression. So what is that expression? Okay, I just write 5. 5 is an expression? Yes. Yes. The interpreter will treat 5 as an expression and it is going to echo you 5. For example, 5 plus 2. The interpreter, what it will do? It will take 5 plus 2 and evaluate it and give the result, right? So this the scheme dialect is going to give you your environment. It is going to give you your interpreter shell in which you can type an expression. For example, you have worked on cell script. You have worked on cell script, right? So there is a dollar symbol and after that you can write a cell scripting and you may get output like that. This is going to provide you a small what is that I can say a prompt. I can say a prompt by which user can able to interact or discuss with the language. Okay, so the expression is a very primitive thing, and it can be of any type. Okay, and the interpreter, as soon as sees the expression, what it does, it displays the result after evaluating the expression. So the interpreter is capable of evaluating the expression. Okay, so let us take a number 432. What interpreter does? It is reading, but there is no logic available, right? I'm just, it is an atom. 432 is an atomic value, and the interpreter just echoes 432. Okay, let's take another thing. So plus 1 3, the interpreter, what it does, it reads your input, and plus 1 3. So what it does, after reading, it is going to evaluate and going to give the expression. Okay, so some of the primitive procedure, actually, if you look at this particular syntax, the Lisp languages very much, you can see a bundle of parentheses, okay, open parentheses and close parentheses like this. And here, the thing is, if you write inside a parenthesis, the first one, what you have to write? The first one is nothing but a procedure. You have to write a procedure name, and then if it is a procedure, what is that? It will be operating on the data. So the data is called as an argument. Okay, for a procedure, you have to supply the argument. So from the next element onward, from the second element onwards, it is reading the data and treating all the data as a parameter to the procedure plus. Okay, so in the Lisp language, plus the operator is called as a procedure. So plus means there is an internal procedure available for plus. Okay, and from second element onwards, it is going to consider that as an argument. Okay, so 1 and 3 is the argument, plus is the procedure, and internally some instructions are defined. That instruction will manipulate read the data, and it will evaluate the data, and then giving the result. Okay, so this concept you have to understand. So what is the concept? Whenever you are start writing your code, first of all you have to write a procedure name. Here plus is a procedure. Okay, all the operators are called as a procedure here. And if you are having a procedure, and if some procedure may want the data argument, so you have to pass the argument. Okay, so plus is the procedure, 1 and 3 are arguments, and this procedure is going to operate on 1 and 3, and accordingly, actually here for the plus procedure, what do you think? What will be the content inside? If you look at internally, for the plus procedure, what will be the content? There may be some machine languages, the machine instructions, okay, that corresponds to plus. Okay, what it will do, for example, here plus 1 3, for this 1 will be loaded in some register, and 3 will be loaded in another register, and then it will call the add instruction, add with this register, that register, etc. Right? So plus is the procedure, and if you look at inside definition for the plus procedure, there may be your machine instructions. the equivalent instructions are available. Okay, that will be executed. Understood? I think so far so good. Shall I go ahead? Can you give echo response?
Yes, sir.
Yes, sir.
Yeah, thank you. Right. So now the expressions, if you look at how to write an expression, the expression is usually written in terms of a prefix notation, and we know prefix notation, postfix notation, and infix notation. We already studied in data structures. Now it is not new to us. Okay, everything we have to write as a prefix notation. Okay, so prefix notation means what? We have to write the operator and then operands. So this is a style we have to adopt. Okay, if you look at the second example, and minus is the operator and the operand we are passing it, right? And then multiplication here, and if you look at the last example, plus is a procedure which may expect any number of arguments. It is up to you. There is no restriction at all. So initially we feel that plus is the binary operator. We have to pass only 2 arguments. Not like that. You can pass any number of arguments. Any number of arguments you can pass. So here in this example we have 4 arguments, and plus is going to read all 4 arguments and apply the plus operator procedure, and it is going to evaluate the value and going to display the value. Okay, so in the Lisp, you no need to write a complex nested expression for adding 4 values or 3 values, whatever, more than 2 values. Okay, you no need to have a nested expression for doing the same operation for multiple data. More than 2 data, you no need to do the nesting. But in a single list itself, you can write everything. Okay, so this is a fantastic feature available in the Lisp language. Okay, if you take this particular expression, how to write a Lisp expression? Okay, I'm not saying the prefix expression. How to write a expression in Lisp language? Okay, so you have to maintain the order of priority. Okay, so we know that the hierarchy of operators, right? So multiplication always have a higher priority than plus. So you have to write this expression like this. Then only the Lisp interpreter will evaluate and give a correct answer according to your expectation. Okay, so you have to write multiple parentheses, but it is somebody told some different expansion for the Lisp word itself. It's a kind of idiot like something. Okay, but once you start writing, it will be easy to write later. You will be fluently writing after some 2-3 hours of practicing. Okay, so if you look at this 10 by 2, you have to write the divide operator 10 to. Okay, so now is something like, okay, 10 by 2 is 5. Okay, fine, but this may also give you a fraction, right? Sometimes, so 5 by 2, it is 2.5. So the Lisp is not going to give the result in 2.5, but it is written in the mixed fraction. Okay, it is going to give you in the mixed fraction. That you have to understand. So whenever you are learning any language, and this is one of the things you have to understand. If you apply the division operator for the integer, what will be the output? Whether it is an integer or it is a real number. Okay, and if it is a real number, how many digits it is going to round, whether it is going to round it or not, how many digits always the language will echo to you, right? So that one you have to understand before writing a complex program. Okay, so this is very, very important. So when you are doing some calculations, the output can be a integer or not. Though the data is a integer, the output is integer, or it is going to take a float value. So in many languages, /10 by 2 will be interpreted as 5.0. 5.0, but here in the Lisp it is 5. Okay, and also in some languages it will be giving only 2 digits after the decimal point. Okay, so whether it is having a rounding capability or not, you just carefully look at the language. Okay, if it is rounding, how many number of digits after the decimal point it will give you. So all those details as a programmer you have to understand. Okay, so in the Lisp language, it is going to give you in the mixed fraction. Okay, there is no rounding, there is no decimal point. After the decimal point, you can't see many digits. Okay, right. This is the point you have to note. Okay. So this also Sriba has explained in the previous session. Right. So in the list, what is the syntax for writing the statements, expressions, operator? I can say it is a procedure actually. In common terms, I can say it is a procedure. It is not operator. It is a procedure and then argument, argument 2, etc. up to argument n. And you can also have a nested procedures, nested expressions. So in that case, what happens? So for OP1, there are 2 values. One is again this, if you are looking at the first value, again it is another expression. Okay, so this expression we are calling it as a combination. So whatever you are writing in the earliest slide, 10 by 2, see slash 10 by 2. So this is called as a combination, and 10, 2, slash and are called as a primitive. Okay, so in the very first slide we have seen that there is a primitive, there is a expression, compound statement, etc., etc. You know. So another word I would like to introduce you, that is nothing but a combination. What is meant by combination? Combinations are built on top of a simple element. Okay, on the primitive element. So this is a combination. How to write the combination? This is the way. This is the way of writing the combination. So how will you define the nested expression? Now, can you tell me how will you define? So if the combination is nothing but operator or procedure followed by the arguments. Okay, this is the combination. How will you define the nested expressions? How will you define the nested expression? How the Lisp interpreter is going to evaluate this? Okay, it will always go to the innermost combination. So innermost combination will be evaluated, and that result is going to be substituted in this particular place. Okay, for example, you have minus 2, 3, 2 minus 3, it will evaluate and substitute in this particular place. Okay, and here you have a multiplication operator, and then 8, 3, 8 into 3 will be performed and it is substituted in this place. So 8 into 3, 24, and here something I said, and then operator, then it will perform the operation. So in the case of a nested expression, what is happening? The Lisp interpreter, how it is behaving, it will go to the innermost combination, okay, read the combination, then process the combination, evaluate the combination, and then substitute the result in that particular place. Okay, so it is a recursive procedure. Okay, so after substituting, it will loop through, then it will go to the next outer loop, etc., etc., till it is completing all the things. Okay. So what is the benefit of prefix notation that also taken in the earlier sessions by Sriba? Okay, this also you know. Right. So now, if you look at this particular thing, please carefully look at read, eval, print, loop. The Lisp interpreter is the characteristic of Lisp interpreter is reading, evaluating, print, and then loop through. The same thing will be continued. Once again, read, evaluate, print. Once again, read, evaluate, print. In this way, it will go on. Okay. Somebody is talking. Please mute yourself.
Ma'am, I'm Reba.
Yeah.
Ma'am, your voice is breaking. I felt like that, but I don't know whether it is for me all alone or for students also. Are they facing that? None of them are responding. Students, someone?
It's fine.
Okay.
Okay, right. So this Lisp interpreter is working in this fashion: read, eval, and print. This will be continued. Okay, because in the case of a nested one, what will happen if you take this particular example? Which one will be evaluated? Okay, innermost one. Okay, innermost one will be read and then evaluate and then print the value and then move ahead. Okay, so this is the way expressions are going to be evaluated. So, and actually in many languages the evaluation will be a kind of lazy evaluation. Okay, so if we are into keenly look into the languages, there are many things. That is, this evaluation will not be, it will read, it will not evaluate, and this will be carried over further, and finally it will substitute. That also another characteristic which is obeyed by some languages. Okay, but here the Lisp is going to use the read, eval, print loop procedure. Okay, right. So now, right, how to evaluate a expression? Usually in the Lisp interpreter, how what is the procedure? How it is going to evaluate? It is reading, evaluating, etc. So it is a theory, right? Internally, what is happening? It is constructing a tree. It is constructing a tree. If you look at this one, the tree, you take there are terminologies like terminal nodes, non-terminal nodes. There is a root, right? So same thing here. The expression, the nested expression, what you are keeping it, okay, will be converted. We can logically think in terms of a tree, I can say. Okay, so if you look at reading from left to right, and there is the innermost expression star 4c, right? That is multiplication 4c. So the multiplication 4c are, it is nothing but a terminal nodes from which you cannot able to see any spanning. There are no child here. For the terminal nodes, we will not have a children, right? So these terminal nodes are evaluated and it is moving upwards, right? So 4 into 6, it is 24. And then what happens? And if you look at that, this is one of the operand for the operator plus. Okay, so for the plus operator, 2 is another child. And what is the next child? The second child is nothing but evaluation, the result of 4 into 6. Right, it is 24. So 2 plus 24, it is 26. And then what is happening? Multiplication. For a multiplication, this is one of the operand, and another operand is this one, plus 3, 5, 7, right? We have to add 3, 5, 7 and then pass the result as a second argument to the multiplication. So plus 3, 5 and then it is added, and that result will be the second operand for the operator star, and after that the star procedure is called for the argument 26 and 15, and it is evaluated. As the result is, you are getting a 390. Okay, so this is called as a tree accumulation. The Lisp interpreter is working in this way. It will always read the expression and it is internally form a tree structure, okay, and then it is evaluated. So that is the point to note. Okay, though you know in data structure there is a tree and given an expression, you can demonstrate the expression in the form of a tree, that is there. But now the Lisp, with respect to Lisp, the same thing is applicable. What you learned, that is we are understanding how the Lisp is going to be behaving. Okay, right. So let us look at here how to evaluate a combination. What is meant by combination? Combination is nothing but the within a bracket procedure arguments. That is nothing but a combination, right? So how the combinations are going to be evaluated, right? So as I told already, I'm just this is the statement from your book, so we are explaining, you know already. So how the combinations are going to be evaluated. So what happens? Evaluate the sub expressions of the combination. You take the sub expression, that is the innermost expression, and evaluate. Apply the procedure that is the value of the leftmost operator, to the arguments that are the values of the other sub-expressions. That is what we have done here, right? So please understand. So while writing how the combinations are evaluated in Lisp, right, you have to state there are two steps. Okay, first step is evaluating the expression. How to evaluate the expression? Apply the procedure to the arguments. Okay, while seeing the arguments can be of another sub-expression, right? So this is the recursive way of handling the procedure. Okay, right. Next, let's move on to naming and environment. What is meant by naming? Okay, so whenever you are in any languages, we have assignment statement. Without assignment statement, how to instruct the computer to do particular logic, right? So here also there are the concept called as naming and environment. How to define a variable to a value, how to assign a value to the variable. Okay, so how to name the identifiers, I can say, right? Okay, so we have a define keyword and then variable name and then the value. Okay, it is like a equal to 10 you are writing. Okay, so how to write it? Define a 10. So there is no equal symbol here. There is no equal symbol here. Okay, so in C language, if you take, there is a hash define by 3.14. Like that, you can just remember that one, but there is no hash. Okay, so define variable name and then value. So you have to just, it will take time to digest, the syntax is a little different, but once you read for 1 week, you can able to fluently write the program. Okay, so define, what is meant by define? So what I said in the earlier case, within a bracket, you can write a composition. Okay, the composition will have a procedure and then the arguments. Here, what is the procedure? Define is a procedure. For a define keyword, there is a procedure defined inside internally. Okay, some machine language instructions are written for define. So what will happen? So define a equal to 10, define a 10. So 10 has to be assigned to a, right? So what is that a? A is nothing but a name. So this is actually what you are seeing is the simplest means of abstraction. What is meant by abstraction? In the object-oriented programming, if you say abstraction, what is that? Can you define what is meant by abstraction? Anyone of you, please? I should not talk indefinitely. So it will be like a one-way, right? What is meant by abstraction?
Basically, hiding the implementation details and
thank you. Thanks for your answer. So abstraction is nothing but something kind hiding something inside a class or object, right? Okay. Now here define A10. What you're hiding here? What you're hiding? After all, the 10 is inside A. Okay, but it is a simple case. It is the simplest means of abstraction. A equal to 10 means what is the detail of A? You are not telling, right? After defining A, you are not telling anyway A has a 10, A has 10. You are not telling, right? You are hiding something. So it can be of 10 or float value or whatever may be. The value itself can be another expression. Who knows? Okay, so this is the simplest means of abstraction. Okay, so now let's take another example. Define size equal to 2. Okay, what we are doing? So what we are doing with the help of a simplest abstraction, right? So what we are doing is here by using the define procedure, we are associating a value to the name. Don't say it is a variable. Don't use a variable word at all in Lisp. Okay, it is a name for something. Okay, so define procedure is going to associate the value to the name, right? Okay, that's what you. So this is the way you have to interpret. Okay, that is the name, that is the value. You are associating value to the name. Okay. So can we write like the *5 size? What happens now? Okay, so star is a procedure, 5 is one of the operand, and size is another operand. But size is what? You have a name. So if you have a name, what happens? What happens? The interpreter will substitute the associated value to this name, right? So 2 will be substituted, right? So actually this language is for the beginners, okay, but you are studying in 7th semester, but you can able to compare the languages when you are reading the list, and you know many languages, okay, you can compare. It's getting a flavor of different things. So one day you will go for ice cream of vanilla, and another day you want to taste something, then you will say comparing vanilla is good than this, right? So now we have to know the what is that, advantages of languages, the flavor of languages. Okay, that is why in some circumstances, depends on the hardware, depends on the operating system, and it depends on the application. You will choose the particular language. You are getting a capability to choose the language. Okay, so now, so the interpreter, what it does is, as soon as it sees the name, it will associate the values, it will substitute the value. Okay, and then, yeah, right. Now you look at this one, define pi. In C language also we will write define pi is 3.14, but in C language what we are calling that as a preprocessor, right? So pre-processing will reduce the compilation time or execution time, whatever, right? So now here there is no pre-processing, nothing. It is after all an interpreter. Okay, so if it is reading a single line, what it does, it is allocating a memory for pi, and then it is associating this value to that memory, right? Then define radius 10, another variable radius with the value 10. Now you're going to write an expression like this, nested expression, nested combinations. So star pi star radius. Okay, so what happens? Star is a procedure, and radius is a name, radius is another name. Yeah, that is a name. So what it will do, 10 will be substituted here, 10, and then the procedure is operating on 10 and 10. Okay, and then pi, while coming here, 3.14 is substituted, and it is doing. So this is the way of learning the language, right? So from the simple element, we are going for a combination, and then the nested combination, and in the combination we can also have a naming. Okay, and naming, what is that? Environment. Environment is referring a memory. After all, it is a memory. Naming and the environment. Okay, so now here, let us take this particular example. Define circumference into 2 pi radius. What is this here? Defining a name called as circumference to a combination. What is that? What will happen? After all, the combination will be read. Okay, that is the procedure, right? It will read, it will evaluate, and then print the data. So 2 into pi into radius. So radius is substituted 10. 2 into pi into, that is 3.14 into 10. It will be evaluated, and it is substituting a value in this place. Okay, and then that value is associated to the circumference. So now we are moving to the little higher level of abstraction, right? So the circumference is nothing but here, if you look at the pi is associated with a single value. It is the smallest abstraction, but if you look at circumference, it is a little bit higher abstraction, because you have a name, you have an expression, everything. It is you are calling a start procedure, right? A little bit higher level compared to this one. Okay, so what is the advantage? What is the advantage if you are going for this kind of higher level abstraction? What is the use of circumference? Okay, if you see in your programming, in many places you have to use the circumference. So what you will do, once you are defining and that value is evaluated, and it will be substituted. Okay, no need to write every time 2 into pi into radius in your language, in your program, right? So this is another advantage of going for a naming. Okay, if you look at the environment for the circumference, what is the environment? It is a memory. If you look at this one, and it is referring this particular logic, right? The output of this logic. So you can have any logic here. You can have any logic here, and this name can refer that logic. It can be a simple logic or a complex logic. Okay. Right. So after this one, wherever you're in your instruction in your program, circumference means this value only. So here in this example, 62.8318, it will refer anytime, right? So let us look at procedures. For all the primitive operations, we have procedures, right? So if you look at a primitive procedure, we have a primitive data. And the primitive data is nothing but integers, right? One of the so far we have we shown only integers in our example. Okay, so you just find out the before the next session what are the data types supported in Lisp. I can say list is the data structure supported. Okay, inside a list you can have an integer, whether you can have a character, whether you can have a string or a boolean. Okay, let us keep it as a suspense, whether it will take a float only, integer only, there is no boolean type. Let us look at in further sessions. Okay, so there are primitive procedures and primitive data. The primitive procedure will operate on the primitive data, and then we can form a combinations, and then by using a combination we can build a nested combinations. Okay, and then we can associate names to the combinations. These are the things you have to know before going further. Okay, so let's look at another example. This is how to define your own procedure. So far, yeah,
Sorry to interrupt.
yeah,
20 more.
I think time out. Okay. Yeah, thank you. Okay, we will continue in the next session. Thank you so much. I hope that you are understanding. But after all, it is a elementary level. So in the next